Hi everyone, we meet again in week 6 part 3 video. We still under chapter 3 which is coordinate system, but now the topic is quadratic equation. Quadratic equation is a review topic, but this topic is required when we go to 3-dimensional coordinate system. Quadratic equation has a polynomial of degree 2. It has a general form of ax squared plus bx plus c, where a here cannot be equal to 0. When a equal to 0, it becomes a linear equation. And then a, b, and c here are constants. Because of the highest degree or highest power of this quadratic equation is 2, so it has at most 2 different roots. The most important part in this topic is we need to know how to graph a function. Quadratic equation has a form of parabola, which is, for example, is given by this shape. A parabola can be opened up and opened down depends on the value of a. If a is positive value, then the parabola is said to be opened up. Otherwise, when the value of a is negative, the parabola is opened down. And then we have a turning point. The turning point is located here and we call it as vertex. To graph quadratic equation, there are 5 steps here. The first step, we need to check whether our quadratic equation is open up or open down. So as mentioned earlier, if a is greater than 0, our parabola is open up, which is given by this curve. If a is less than 0, so our parabola is open down, which is given by this kind of curve. And then step number 2, we need to find x and y-intercept. To find x-intercept, we need to solve a function of fx equal to 0. Means that here you need to use your knowledge on how to find roots of equation for quadratic equation. And then to find y-intercept, we need to evaluate a function when x here is given by 0. And then step number 3 is we need to find vertex. The formula to compute vertex is given by x equal to negative b over 2a. So the vertex can be computed by using this formula or by completing the square method. And then we need also additional points. So this additional point can be computed using symmetry about x, about the axis. And then step number 5, by using all points that we get from step number 1 till step number 4, we can sketch or plot the graph and join all the points. Okay, to ensure the understanding, let's solve this example 1. So we need now to sketch a graph of fx equal to negative x squared minus 2x plus 3. In this case, we have learned previously, our step number 1 is we need to check the value of a. So the a value now is negative 1, which is it is less than 0. Means that the graph is open down. The graph is like this. And then step number 2, we need to determine y-intercept. How to determine this y-intercept is we can set the value of x equal to 0. That is, we need to substitute x equal to 0 in this equation. So all x here become 0. When we solve this, we will have got our y equal to 3. Means that we will have point here. The y-intercept is at x0 and y equal to 3. And then we need to determine x-intercept. How to determine x-intercept is by setting our y equal to 0. In this case, when we set y equal to 0, we will have this kind of quadratic equation. When we rearrange this one, we have x squared plus 2x minus 3 equal to 0. Means that this one is, we need to solve a roots of the equation. How to solve roots of this equation? We can use factorization method. That is, we have x times x. So we got here x squared. And for this one, we have negative 1 times 3. So we multiply this both values, we got -3. Here we will have, when we factorize x minus 1, x plus 3 equal to 0. By solving this, we will have x equal to 1 or x equal to -3. So by using factorization, we will got here two solutions for our x values. And then the x-intercept are this -3, 0, and also 1, 0. So these are two values of our x-intercept. Step number 3 is to determine vertex. How to determine vertex? We need to use formula x equal to -b over 2a. In our case, our a equal to -1 and our b equal to -2. Means that here when we compute x equal to -2, this is b, over 2 times -1, which is equal to -1. That is given by this formula. And then we can substitute x that we got here into our original function. That is, we have here f -1 equal to -1 square minus 2 times -1 plus 3. When we solve for this one, we will got the answer equal to 4. So the vertex here is -1, 4. And then the next step, we can determine extra point. In this case, let me choose our x equal to -2. You can choose any value of x here. When we choose x equal to -2, and then we substitute in our original equation, so we'll have got here the answer equal to 3. Means that the value for x and y here equal to -2 and 3. This is our additional point. To recap the points that we have found here, we have y-intercept 0, 3, x-intercept -3, 0 and 1, 0, our vertex -1, 4, and we have additional points -2, 3. In this case, how to plot? We have here x and y exist. So now our y-intercept, let's say we have here 1, 2, 3. So this is point 0, 3. And then we have our x-intercept -1, -2, -3. Here is -3, 0. And then we have here 1, which is here 1, 0. With another x-intercept. And then our vertex -1, 4. Let's say here is 4. So somewhere here is -1, 4. And then we have extra point -2, 3. Let's say somewhere here, we can connect all these points. Okay, we can connect all these points. Roughly, we have this kind of parabola. So when we sketch the graph exactly, we will have here graph for this quadratic equation. Now, I want to show you how can we plot quadratic equation using Geogebra. This is a link of Geogebra. You can input your function here. Let's say we want to plot our example 1, which is f equal to -x to the power of 2 minus 2 times x plus 3. Geogebra will give us automatically the output of this parabola. Now let's go to this example 2. Let's say we have fx equal to 2x squared plus 4x plus 5, and this question asks us to sketch a graph. First step, we need to check a value. A value here is equal to 2, which is greater than 0. Means that our graph is open up. Then the second step, we need to determine y-intercept, which is by setting x equal to 0. When this x equal to 0, we substitute in our fx, we will got our f equal to 5. Means that y-intercept is given by 0, 5. Then we need to determine x-intercept, which is by setting y equal to 0. This one, when you solve it by using formula, quadratic formula, or you can use your calculator, you can see x now is a complex number. Means that there is no real number. In this case, there is no x-intercept, hence x-intercept does not exist. Step number 3 is to determine vertex. We can use vertex formula, which is x equal to negative b divided by 2a. In our case, a value is equal to 2 and b value is equal to 4. So x here equal to negative 4 divided by 2 times 2, we will got the answer equal to negative 1. And then this x value equal to negative 1, we substitute in original function. That is, we'll have f negative 1 equal to 2 times negative 1 squared plus 4 times negative 1 plus 5. We'll got here the answer equal to 3. Means that our vertex or turning point is negative 1, 3. Step number 4, you can determine extra point here. Let's say we choose x equal to negative 2 and then we substitute in our original function. So we'll got here the answer equal to 5. Means that we have extra point negative 2, 5. Let's recap what we have done so far. We have y-intercept 0, 5. X-intercept does not exist. Our vertex negative 1, 3. And we have extra point negative 2, 5. So how we can plot here? Let's say we have this Cartesian coordinate. So y-intercept is given by 0, 5. 1, 2, 3, 4, 5. Means that our location of y-intercept is at this coordinate. And there is no x-intercept. And our vertex is negative 1, 3. Means that negative 1 is here and then this is 3. This is our vertex. And then we have here extra point negative 2, 5. Here negative 2 and then negative 2, 5. So this is our extra point coordinate. When we connect all these points, we will have roughly graph like this. Instead, exactly our graph is given by this parabola. We can plot our quadratic function of example 2 in Geogebra. So this is the input function and this is the output function or the graph of our parabola. Let's review what we have learned so far. You have learned the introduction to one-dimensional, two-dimensional, and three-dimensional coordinate system. You also learned about linear equation and how to graph the linear equation. And later in this Week 6 Part 3 video, you have learned about quadratic equation and how to graph of the quadratic equation. So next, we need to know about nature of the roots of the quadratic equation. Thank you. See you in Week 6 Part 4 video.